So today we were like day before yesterday we completed this particular Wheatstone breeze and Kirchhoff's law, uses of Kirchhoff's law and all, isn't it? Now today we are going to start with something called as like we were going to do the we are trying to understand how to find the equivalent resistances, isn't it? Not only using Kirchhoff's law, this equivalent resistance is just find out using the normal methods. Got it or not? Later on, we will understand how to find the equivalent resistance with the help of Kirchhoff's law and all. Are you able to get me or not? Okay, so let us understand what are the major points in this equivalent resistances case. So there are many considerations. Like the first consideration in the equivalent resistance is with the help of rearrangement of circuits. Okay, ठीक है ना? So basically how to do it, the first process means the first way to find equivalent resistance is I can rearrange my circuit. So it says that rearrange the circuit, okay, keeping every device connected across same terminal. Word or not? And because the point is each conducting wire have same potential, okay, so each point of wire have same terminal. So देखो बोल क्या रहा है कि there are two ways to do the rearrangement of circuit. First is rearrange the circuit keeping every device connected across same terminals. What you do, just rearrange the whole circuit by keeping all the devices connected across whole terminal. And second thing is that if in that circuit, if there is a conducting wire, then you know that the conducting wire has the same potential. So that is why the all the terminals of the conducting wire also have the same potential. Are you able to get me or not? Okay. Second case is that in this you can find if first thing is rearrangement, second thing is in some circuit you can see that there is a folding symmetry. Okay, so now look over here uh, how to understand whether there is a folding symmetry or not and how to find its equivalent resistance. So if in a circuit uh, if the circuit if the circuit is symmetric, okay, about line joining about line joining terminals, okay, then like then up and down or left or right, go down means if you find that on the line joining terminals up and down it is symmetric or left or right it is symmetric, go or not? So then these circuits are same and symmetric, these circuits are same, or you can say, and then symmetric points uh, have identical potential. If you find that up and down or left and right, the particular condition is that the particular symmetry is there, and if the symmetry is there, then all those opposite equivalent points will have how much potential? Same potential. Are you able to get me or not? Okay, so then what we can do, so we can fold the symmetry, means, so what we can do after that is, so we can uh, fold the circuit, right or not, and overlap and consider overlap resistance in parallel. How we will consider the resistances? Yeah. Okay. So first point is, if they have same potential, you know that the overlap resistances can be easily considered in terms of parallel. Are you able to get me or not? But there is a big note about that, that this symmetry is also valid when one side when one side is n times of other side in circuit. This symmetry is also valid if one side resistance are n times of the other side resistance. Are you able to get me? Got it or not? Yes? Is that clear? Got it? Okay, now look over here. Then the yeah, then also it is in parallel. It will be considered in parallel. The third kind of equivalent circuits are the circuits which follow reverse symmetry. Hold on. The meaning of this is, if circuit is symmetric, the point is, if circuit is symmetric about in and out, okay, like how many currents are appearing and how many currents are going. So if the circuit is symmetric about in and out terminals, or perpendicular line, or perpendicular bisector of line, you can say. Word or not? Means, like, if the connection is like this, resistance, 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 and this kind of symmetry is there. This kind of resistances are present. Are you able to get me or not? So these are the followers of reverse symmetry. क्या बोलते हैं इसे अपन? Yeah. So, or perpendicular bisector of line joining the terminals, or the perpendicular bisector of line joining the terminals, then symmetric branches have same identical currents. Yeah. No, they are at not same. Means they basically you can consider that they all are in kind of series. So basically they have the same currents. Are you able to get me or not? Yeah. Is that clear? And the last use which we were talking, the fourth one, is the use of KVL, Kirchhoff's voltage law. No, it or not? Are you able to get me or not? So how to apply this? Then we don't, we just connect the connect बोलता है connect an ideal battery But we will understand how to use KVL in a much more better way, okay? Because this is not just one statement. So connect an ideal of yeah, zero resistance. Okay, ideal battery means zero resistance. So connect an ideal battery of EMF V, okay, across terminals. Word or not? And distribute the currents in branches. The question which you sent me of cube, okay, is solved using this method. Yeah, that NCRT question of cube. There are resistance in the terms of cube. Okay, so basically the point is connect an ideal battery of EMF V across the terminals and distribute the current in the branches. That means that current through the battery, consider the current through battery to be I. Right or not? Then by equations of KVL, find the relation between V and I. Right or not? And then simple R equivalent is nothing but net voltage of battery divided by current in the cell. Are you able to get me or not? So these are the four steps which we usually follow to find the resistances and all. Are you able to get me? Yeah. Got it. Is that clear? Should we start? So first I'm considering a arrangement of circuit, means rearrangement. Word or not? 1 minute. Hello? हाँ संस्कृत tell me. हाँ 2:30 at 3 हाँ 2:30 you guys can come. 2:30 पे मैं तुम्हारा डाउट क्लियर कर दूंगा. ओके हम लोग की टेस्ट चलती रहेगी. हाँ 2:30. ओके चलो आगे बढ़ा जाए. तो ध्यान से देखो. So I have been given this circuit. It is telling that find the equivalent, find the R between equivalent resistance between AB. तो ये एक तरह से पता है ये कभी भी इस तरह के क्वेश्चन आए इस तरह के बहुत सारे अरेंजमेंट वाले बेसिकली दे आर रीअरेंज्ड क्वेश्चन. क्या बोलते हैं इसे अपन रीअरेंजमेंट्स. क्या करते हैं we can see that these two are in series, isn't it? So basically if they are in series, so this resistance is how much? 4. And that 4 and this 4 are in what? Parallel. So once again I'll get how much? 2 ohms. Yes. And then 2 plus 2 is how much? Once again 4. And this 4 and this 4 is once again in parallel. So once again I'll get how much? 2 ohms. And this 2 and 2 once again is in how much? 4. And once again 4 and 4 is how much? Parallel. So once again I'll get how much? 2. 2 and 2 once again is how much? 4. Are you able to understand me? It is. So it's basically we are bringing down to only one equation or not. So this is called as rearrangement only, now. Yeah, yeah, that's all. So 2 and 2 is 4. So basically this is like something like this way. Means I don't write all the things. Okay, so this is 2 and 2, 4. So 4 and 4 is once again parallel. So their resistance is 2. 2 plus 2 is 4. And once again 4 and 4 will be parallel, isn't it? तो उनका भी रेजिस्टेंस 2 हो गया. 2 plus 2 is once again 4. 4 and 4 is once again parallel. So this resistance will also become 2. 2 plus 2 is how much? 4. So equivalent circuit is looking like this way, isn't it? Equivalent circuit is like this way. This is A, this is B, this is 4, and this is also how much? 4. So R is how much? Just 2. So R between AB is just equal to how much? 2. Are you able to get me? Is that clear? Write it fast. Got it? Mm-hmm. ठीक है, एक मिनट. I'll give you one more question. Hmm. Okay. Now I was talking about rearrangements. Now you see that there is one more question. बोल रहा है कि let's suppose this is A and this point is B. Okay. So we are doing the first part only, rearrangements of resistors. Got it or not? बोल रहा है कि let's suppose this is one resistor, and this is also one resistor. 2 ohms, 2 ohms, and this is also how much? 2 ohms. And I connect this point with this point with a simple conducting wire. Then question is find the resistance between AB. Find R of AB. जल्दी बताओ. Next question is same thing, but just a little bit twisted. It's connected like this. Do it fast. First this one, then we'll do this one. Can you do it? ठीक है, बताओ क्या होगा. अच्छा, this is basically the question of arrangement of this is the particular arrangement of circuit. So look over here. How to do it? See, this is consider basically we do this with the help of naming. Let's suppose this is 1. Okay. Now you see that I have another potential over here or not. I call it as 2. Are you able to get me? But then here I have the same potential 2 or not, because they are connected by a conducting wire, isn't it? Yes. So basically, this circuit has changed to what? Similar, like I'll just mark A and B first. A, B. Now A is at 1, isn't it? And I'm going to 1 to 2 basically. So if I'm going from 1 to 2, I have one resistor, isn't it? And at point 2 basically my B point is there or not? ध्यान से देखो तो B point is at my point 2 or not? Yes? Are you able to get me? So 1 to 2 I have one resistor. Then once again you see 2 to 2, is this is something different or not? That what is happening, that when I connect with 2 to 2, these particular 2 ohms and 2 ohms has happened what? Because I can't go from 2 to B now or 2 to 1, isn't it? So what has happened, that they have become sorted. इसको क्या बोलते हैं? Sorted. The meaning of that is, the point is very very simple. You should always remember that the current always selects that path which have less resistance. Word or not? Which have what? Balak? Less resistance. So see that if I see this wire and if I see this wire, which wire has less resistance? 2 to 2, isn't it? So what happens? The current actually goes from here to there, goes from here to there, comes here and then gets out. It never goes in this. So in this region, the current is how much? 0. So therefore, the only resistance between A and B is just how much? 2 ohms. Are you able to get me or not? So in that 2 ohms and 2 ohms, there is no current only. This is called as the major impact of conducting. Mm-hmm. Right now, I told now that the current always selects the path which have less resistance. Here I have more resistance, and here he is in conducting wire. There is a zero resistance or not. So that's why it will always select a path which have zero resistance. Are you able to get me? Got it? Do the next question. Same pattern but different one. Do it fast. It's easy busy. Once again, see, once again how to arrange. Mark this point as what? 1. This point is what? 2. Sorry, 1. Yeah, you can mark it as A also, no problem. And this is connected with B now. So this point is B or not? So here, if it is a conducting wire, this is also what? B. And here it is also A, isn't it? Are you able to get me? Here the wire looks like this way. 1 minute. Alright. Why it's not getting erased? Acha, that was a image actually. It's like this way. Okay. Well done. So now look over here. Once again, I'll write A, B. Now you see that there is 1 2 ohm between A and B, isn't it? So start. There is first 2 ohms between A and B. Then once again, B to A, another resistor. Then A to B, one more resistor. So this is called as rearrangement. Got it? Are you able to get me? So what, whenever you see such kind of circuits where there is a conducting wire, rearrange the circuits. Got it or not? So this is 2, this is 2, this is 2. So R equivalent is how much? 2 by 3 ohms. Are you able to get me or not? Because all are in parallel. Is that clear? Are you able to get me? Next, arrangement. These are some basic questions which we'll do fast. I think you have a doubt in this kind of question. ऐसा कुछ क्वेश्चन दिया जा रहा है? There was a question like this. Point A and point B. Let's suppose this is R, this is also R, and this is also R. Find the equivalent resistance between AB. So once again, conducting wire, no? So this is point A, and this is point B or not? Now, it is connected over here with A. So this point has also same potential A, got it or not? And this has also same potential B, that's all. Then you mark A and B. Start. 1 R. Yeah, all are in parallel. B to A, one more. Yeah, that's all. That's your answer. A to B, and all are R, R, R. So therefore, R equivalent is how much? R by 3. Is that clear? Okay. One more kind of example you might get is this kind of circuits. Oh, one more field I have to take. Isn't it? What they do? The first question is this. This is point A, and this is point B. This is R, this is R, this is R, this is R. Find the equivalent resistance. Got it? Yeah, A point is not completely touching the surface. In both cases, you have to find R between AB. Okay, in first case, once again, अच्छा एक बात बताओ, this whole thing is set up by your conducting wire or not? So if this is point B, this is also what? Point B. This is also point B. This is also point B. And this is another point origin O. Are you able to get me or not? I have to find the equivalent resistance between A to B, but in between that there is a origin O, isn't it? Got it? So what I will do? Simple. A, O, B. I'll mark like this way. Okay. Now A to O, one resistor is there. So go with one resistor. Then O to B, another resistor. Isn't it? Then once again O to B, one more resistor. O to B, one more resistor. Right or not? So look over here. When you connect them, one, two, three, they are R, and A to O, one more resistor. So basically, what kind of circuit is? First three parallel and then with series. So इसका क्या होगा? R by 3. R of OB क्या होगा? R by 3. So therefore, R of AB is how much? R of AB is R plus R by 3, which is 4R by 3. That's your answer. Why or not? Here, A is at center and B is on the conducting wire. So this point is also what? B, 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 and B. So all four are in parallel or not? If I take A and B, then all four are in what circuit? Parallel circuit. Got it? Two, three, all are in parallel. A to B, A to B, A to B, all are A to B only. Got it or not? And all are R, and R. So therefore, once again, R between here AB is how much? Simple R by 4. So these are the questions which are based on what? Arrangement of resistors. Are you able to get me or not? Is that clear? So my concept. Okay. Now let us second one, which we were trying to understand, was called as folding symmetry. Yeah, let us do some more arrangement of questions. Okay, then we'll go to symmetrical types. Okay, 1 minute. You write this, then I'll move ahead. Okay. Some more arrangement of atom we will do. Okay. So here also I have one more question. बोल रहा है कि let's suppose I have a circuit like this way. Then find the equivalent resistance between AB. Okay. Yeah. Mm-hmm. So I have to draw. I think I'll have to draw Q as an even pattern. Tell me. Acha, basically one hint is there. This is based on Wheatstone bridge also and arrangement also. Acha, can you see one thing? That this point is A. Consider this point to be A. This point is B, O, and D. And let's suppose this is R1, this is R2, this is R3, and this is R4. Isn't my R1 into R4 is equal to R2 into R3? देखो तो R1 क्या है? 2 into 6. Here it is 4 into 3. So this is 12 ohms is equal to how much? 12 ohms. So basically, the current through this is how much? 0. Yes? Current through that is 0 or not? So net equivalent equation will be what? Let's suppose there are two resistors. So first one is there are two resistors between A and B, isn't it? Then once again in second circuit, because this is now disconnected, almost disconnected, isn't it? And the third one is simple, just R. Got it? So this is 2R, this is 3R, this is 4R, this is 6R, and this is R. And this point is A, this point is B. So net 3 plus 2 is how much? 5. So R equivalent, well, I'll write it. 1 by R equivalent is what? 1 by 5 plus 6 for 10. 1 by 10 R plus 1 by R. So can you solve it or not? So this gives me R equivalent 5 to the 10. So basically 10R by 13. I can write it, isn't it? 10R will be LCM 10 plus 2 plus 1. So 10R by 30. Is that clear or not? Got it? So this is how you are going to solve this kind of questions. Okay. Next, the last kind of arrangement which we get across is my cube kind of problems, isn't it? Where many guys faces problem. Cube, like they tell us, Control C, A, delete, Control C, Control P. So basically, they tell you that there are cubes like this way in form of resistors. Go ahead. तो इसको छोटा कर देते हैं. Okay, is that clear? And I connect all these edges. Got it. Let me mark some points. This is A, B, C, then D. This is E, F, G, and H. Hold on. Question is very simple. If each बोल रहा है resistors of R each are placed on every side, Go ahead or not? Find the equivalent resistance between, find R equivalent between first case A and G, second case A and C, and third case A and B. बताओ. Which one is correct? What is the answer? Ajay, I'll tell you frankly, this one will be very, very confusing to understand. Let me make you understand this, how to do this. Okay, go ahead or not. Control P. Okay, let me erase all of this. Delete. Now I can do first question. Okay, how to do it? First question is that find the equivalent resistance between A and G, isn't it? Let me paste it in other pages also, because I have to do 3 questions. Okay, now first question is find the equivalent resistance between A and G. So what you do? The first step is connect these things with the battery. मान लो कि they are connected with a virtual battery. क्या जैसे connected है बेटा? Yeah, they are connected with a virtual battery. Okay, go ahead on. Which is providing some current through it. Are you able to get me? And let's suppose this battery is of potential V. See, this battery is of no use. Just to understand the current direction we are including it. Now the current will move like this way or not? I1, I2, and I3. Are you able to get me? And here also the ending will be also same or not? See, if I1 is coming from this edge, so the I1 must end up over here. अरे टेढ़ा क्यों जा रहा है भाई? I1, I2, and I3, because we know that according to KVL, net current across the battery is how much? I only. Is that clear or not? So this is called as KVL method, which we were discussing. Are you able to get it? But this is not a proper use of KVL, just a simple method. Is that clear? Got it or not? Now you see that what is actually happening. See, this point you see and this point you see. Basically, I1 will be distributed in three more parts over here at point E or not. Yes? So see that. Let us understand the distribution. So first point is my A and then my point is E. What is happening? That I1 is getting, see, the point is very, very simple that when you come to G, you should get the net current. Whatever current is applied at A, the net current must be coming out at G. Are you able to get me or not? समझ में आई बात? Yes. So what is happening that when I send I1, I1 is getting distributed into how many parts? Three parts at point E or not? अरे कुछ तो बोलो हाँ या ना? Yes. Now look over here. See, first thing. Now, whatever I can say that. Let's suppose here point A is that. So that means potential at point A is how much? V of A. Are you able to get me? V of A is for how many resistors? Can you identify? One, two, and three. Because yeah, each each is have one resistor or not. So V of A is there for how many resistors? Three resistors. Got it. So first part is done. That I know that between A and E there are how many resistors? Three resistors. Is that clear? Got it? So look, this is point A and this is point E, and each of R is there. Now go to point E and go to point E. Once again, the current I1 is divided into how many parts? Three parts or two parts only? Two parts, na? Yeah. Got it or not? So basically, yeah. So basically, this is V of E. V of E is common for how many edges? One and two, isn't it? So let's suppose, and here it is going at F, isn't it? So mark point another point as F in between it. Got it? So look over here. F and yeah. Kind of. ठीक है. So E to F first circuit is there, means at point E there are distributions of two resistors, isn't it? So one, two. Got it? Now this is potential at E. This is potential at E. Now once again, when it is appearing at H, what is happening? It is once again going as I1 to G or not? Are you able to get me? What you were saying? See, basically here, this is I1 got divided into two parts. Then once again here I'm getting I1 over here or not. At H I should get I1 or not ultimately. Yes. Are you able to understand me? See, this is point A. देखो ध्यान से देखो ये पॉइंट ए है इस पे करंट तीन पार्ट्स में डिवाइड हुआ I1 I2 एंड I3 ठीक है समझ में आ रही है बात तो दिस इज V ऑफ A and this is V of G अब ध्यान से देखो I1 went over here and it got divided into how many parts which are for two resistors. This is potential V of A. Once again, this I1 will come over here. This will come over here, and I2, which is going like this way, will divide into once again two parts or not? Correct, now. So if it is getting divided into two parts, this is potential D, isn't it? V of D. And once again, it will come over here. So it will add and make it the current. It should make the current I1, isn't it? बनाना चाहिए ना तभी तो करंट भाई जी के पास नेट करंट आई आएगा बाहर अदरवाइज कैसे बाहर आएगा मैंने क्या बोला पहले जितना करंट इधर डिस्ट्रीब्यूट हुआ उतना करंट इधर इट शुड कम फ्रॉम ऑल दिस थ्री साइड्स और नॉट if it does not come then how you will get the net current I the output should be always I or not I got you got it so now the point is very simple that if this current if this current is exactly equal to I1 and this is getting distributed into two parts so whatever is the potential of E must be my potential of D so first condition is that potential of V and D are exactly equal to V and E isn't it are you able to get me and then I3 is getting distributed once again into how many parts two parts isn't it and once again here I am getting how much I3 after combining with VD isn't it so basically, the point is these all diagonals must be in same potential. This also are you able to get me? Is that clear? So point is this is V, D and V of B, whatever is that, they are in same potential. Got it or not? Because they are, here the current is divided into two parts, but ultimately it is resulting into same current in the third circuit, isn't it? So these two divisions must be at same potential. So E, D and V have same potential. Are you able to get me? Now look over here at F. This is V of F and this is my point C and this is my point H. इन तीनों में से current कितना आ रहा है? 1 only current are going out of their that or not. And ultimately they are ending up at net current I1 plus I2 plus I3. So that means what? F, H and G are at same potential. Got it? H, F and C, sorry, not G. They are at same potential. Got it? So when I start, so at E there are two divisions, 1, 2. At D also two divisions are there, 1 and 2. I don't know. And then for B also there are two divisions, isn't it? Are you able to get me? And once again, at G there are three divisions. Are you able to get me or not? So 1, 2, 3, 4, 5, 6. Got it? Got the idea? So you see, first three divisions, three currents. E, D, and B, two divisions were there. So each are at same potential. And if was receiving 1 current, so they are at same potential. So they have always connected, and they are always connected with E and H, isn't it? So that's why E was connected with E and H. Look over here. E is connected with F and H. D is connected with B and C. Got it or not? Are you able to get me or not? D is connected with H and C, so H and C. B is connected with F and C, F and C. So they are making these circuits. Okay. Are you able to get me? So basically, this is how much? R by 3. This is how much? R by 6. This is R by 3. So therefore, net R equivalent between A and G is how much? R by 3 plus R by 6 plus R by 3. Is that clear or not? So which is equal to how much? 5R by 6. Is that clear? Got it? Then between A and C it is asking. Second, once again you have to draw the battery. Yeah. So connect this with the battery. Mm-hmm. Are you able to get me? So net current through this is what? I. Receiving is also how much? I. It is getting divided into three parts. I1, I2 and I3. So first thing I got my point A and point C, and from A there are three divisions, isn't it? Done. First task is done. They will definitely meet at somewhere. We know that. But that is first task is definitely done. Now this is potential V of A. Here I should get V of C. Mark that I should definitely end up getting I1, I2 and I3 over here. अरे कुछ तो बोलो हाँ या ना? Yes. So at once again at C there are three same conditions, same potentials, isn't it? So once again at point C I'll end up what I'm doing. Yes. Put it. Definitely I'll get like this, isn't it? Then I know that there are some 2 points in between it. Are you able to get me? Are you confirmed? Okay, then do it. I do it. This is a little bit tedious one. I think you can't solve it using this way 3 division. 1 minute. Let me erase this. It will not be like this. I think so. Mark A and mark C. Mark the currents also. But I think something little bit weird will come up. I'll tell you why. Asa, at point E, the division is how many? Two divisions. At point D, there are how many divisions? Two divisions. At point B, I have how many divisions? But see, B can directly end up at I3 or not. D can directly end up as I2 or not. And G can directly end up as I1 or not. Are you able to get me or not? So this is what is the biggest point over here. That uh, at IC means all after division at E, B and D, there are means they are directly ending up at one point. Means specifically at D and B, they are giving the result I2 and I3 at point C. Means D and B are directly connected to point C. कुछ तो बोलो हाँ या ना? ठीक, और बी और डी से सिर्फ दो ही रजिस्टर्स हैं which are giving the direct current I2 and I3. So first these are my two resistors which are giving the direct answers to C. Got the idea? Okay. And then my point E is there, from where once again there are two divisions. And once again you see there is H, where once again how many divisions? So in H, the net current is appearing from this side. But still there is two divisions, isn't it? And G also is there, where I have how many divisions? Two. And F also I have almost how many divisions? Two. So see, E, H, F and G, they are basically those kind of circuits where I have two divisions. Got it or not? Okay. Okay. So look over here. Let us do. Let us understand what is happening. So I know that A and E is totally a independent one, isn't it? Why? Because this I1 will only repeat at G and C. So there is one more G, which is independent one that will end up one current I1. Yeah, because I2 and I3 can directly end up over here. Means they are lying in this plane only. But I1 is rotating everywhere, isn't it? उसको बोल हाँ है ना? Now, yeah, and B and D are at same potential, isn't it? Because they are ending up directly at IC. Got it or not? Just after two divisions. So A to D, one more resistor is there. A to D, one more. Got it? So this is my circuit. Now, after that, what is happening? At point, ध्यान से देखो, point E, if I look at point E, there are how many divisions? Two divisions. And at H, only one current is appearing or not? And the current which is coming from here at F, that is also means what is happening? That is also getting coming over here, and this current after merging over here is ending up at one current or not? Yeah. If no, if at not two currents, look over here. See this. See. What is happening in H? The first tertiary. See, if this is I1, so let's suppose this is I1 dash, and this is I1 double dash, isn't it? So once again here, whatever the current is coming and I1 dash, they are adding and resulting up in one current or not. Here also, from here I1 dash is appearing, and here also one current is appearing. So they are resulting in only one current or not. Are you able to get me? And then from G I am getting I1. So G to C, one more resistor is there. G to C directly I am getting one current I1. E to A, there is distribution of current I1. Got it or not? And then lies the point. Then lies my point specifically. 1 minute, let me make it little bit up. Okay. Then lies my point H and F, only where the currents are meeting up. Got it? So this is point E. Now look over here. So E to H, one resistor. Got it. Then H to E to F, one more resistor. F to G, one resistor. And H to F, H to G, one more resistor. So this is your circuit. ठीक है? Are you able to get me? And then we forgot about B to F, and D to H. There are two more resistors or not? So the circuit will look like this way. The resultant circuit is this way. Okay. So and this is R, this is R, this is R, this is R, 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 and R. You can see that this part and this part are totally symmetrical or not, and their cross product is also similar, isn't it? So basically, net current through this is how much? Zero. Both of them is how much? Zero. Because H and F and B and D are at same potential. Got the idea? First I1, I2, I3, then at D and B directly ending up at C, so B and D are collected. Then I1 was rotating, through E and G, means it was coming at E and ending at G. So E and G 2 points. Between that there were two distribution at H and F. So H and F, and then I connected all of them. Are you able to get me? Yes. So basically this is how much? R by 2 plus R. And this is R by 2, R by 2, R by 2 plus R. So look over here, what kind of circuit I'm getting. Basically, can I consider this whole thing as 3R by 2? Because this is R by 2 plus R. So 3R by 2. This is once again R by 2 plus R, which is 3R by 2, isn't it? So, yeah. And this is, so basically between A and B, the circuit is like this way. Okay. So this is 3R by 2. This is also 3R by 2. This is also, this is just R by 2, isn't it? R by 2. So A and B. Can you find the net equivalent resistance then? R is what? R equivalent is equal to, it is A and C, sorry, not B. 3R by 2 plus 3R by 2, that is 3R. And this is how much? R by 2 plus R by 2, R. So 3R into R divided by 3R plus R. So basically it is equal to 4R by, 3R by 4 ohms. This is my equivalent resistance. Is that clear? Got the idea? Can I move ahead? Yeah. Moving to next one. I told you the last one was to find between A and B directly. Just A and B. Let's connect this with the battery. Got it? So this is V of A, V of B. Once again current division, I1, I2, I3, isn't it? Ending up, should end up like this way. I3 is same, isn't it? So one thing is very good, that A to B, one resistor is common. Because I3 is directly ending up. So A to B, one resistor we got. Then all these points will once again create a problem, isn't it? So draw करो, जल्दी करो. Try to do it by yourself first, then I'll do. should I help? अच्छा देखो, D, I2 is getting divided into two parts from D. I1 is getting divided from two parts at point D, isn't it? तो कुछ तो बोलो हाँ या ना? Reply नहीं है. And then at F, from all other sides, it is directly connected with B or not. So definitely I1 should end up like this way, isn't it? And here from this side, I2 should end up. अरे कुछ तो बोलो हाँ या ना? Then only the net current will be I over here. Yes? So look over here. D and E, there are two divisions, and you can see that at C there are two collectors, and at G also there are basically two collectors and one down, isn't it? कुछ तो बोलो हाँ या ना? Yes? Yes? So basically the point is very very simple, that we got to know that one point is 1 minute. I think it's not G. Let me check once. So at D and E, I divide into two parts. Okay, and then once again, how it is going. So let me mark that. First point is D and E, isn't it? And then H, I have once again E to H, one more circuit is there, and C is also a collector. So another point is definitely C, isn't it? And then from F, okay, correct. So from F, I'm also getting one more current, I1 or not. I1 is this side, I2 is this side, I3 is this side. So F and C must be at common potential, isn't it? Are you able to get me or not? Yes. So between D and E, let us just connect them. A and E, there is one resistor, and A and D, one more. Okay, so here also I will get these kind of circuit. Okay, and C and F, D is connected with two points at C and F. Got it. Next, D is connected with H, which is, and E is also connected with H, isn't it? So H is my common point. Are you able to get me? And F is connected with G, and C is also connected with G. Got it or not? And H and G are connected with one single resistor. So connect them. That's your answer now. Okay, got it or not? So you see what I am doing. I first divided I1, I2, I3, and then I divided receiving of I1, I2, I3. Then I mark that where I1 is divided, I1 is divided into two parts, and which is D and E, and I2 is also divided. Basically, I1 was divided into two parts at E, and I2 was divided at two parts into D. So D and E definitely must be at common potential. Got it or not? Then I know that F1 is a receiving of I1, so F will be collected over there, and C also is a receiver of I2, isn't it? So ध्यान से देखो, I1 was divided at E, I2 was divided at E, and then it was received at F and received at C. So therefore they must be also at common potential, and between D and E and F, C and F, I must receive the I1 and I2. Are you able to get me or not? Got it. And then you see that E is connected with H. Last one, single circuit does not matter. It is very easy. So E to H, one connection is there. G to C, one connection is there. Got it or not? So therefore, I'll just connect them, G, C, and F and C. Are able to get me or not? So E to H, one resistor, and then D to H also there is one resistor. So this circuit will be also like this way. And similarly, G to C and F to C, one resistors are there. Correct or not? So let us connect them. Anything is left? How many sides are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Two more sides are left. Which one is left? D2C, one more resistor is there. And then E2F, one more resistor is there. Oh, nice, isn't it? Got it? So let me mention R, 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 R. So this is how much? R by 2. This is how much? R by 2 and plus R, isn't it? How much will be that? 3R by 3R by 2 plus R by 2 plus R. It will be 4R by 2, no? Yeah, got it. So basically, the point is, let us mark now A and B. So the first circuit 4R by 2, isn't it? Yes. And can we just do one more thing? This is R by 2, R by 2, R by 2, R by 2. This is how much? 2R by 4. Okay. ध्यान से देखो. अच्छा, let us do one thing. This is R by 2, this is R by 2, this is how much? R by 2, isn't it? So basically, what I will get from there? I'll get, write it, R by 2 plus R by 2 plus R. So basically 2 common, R plus R plus, this is basically 2R, isn't it? Are you able to get me or not? So upward circuit is 2R. Got it or not? And that 2R is connected with parallel with R by 2 or not? Got it or not? So 2R in parallel with R by 2. So 2R in parallel with R by 2 means what? This implies that R equivalent over here is 2R into R by 2 by 2R plus R by 2. है कि नहीं? So this results in how much? 2R by 5 basically, isn't it? Are you able to get me? Then 2R by 5, this I have solved till this, right or not? 2R by 5. Then 2R by 5 is in series with R by 2 and R by 2 or not? So this is 2R by 5 plus R by 2 plus R by 2. And one more connection is between A and B, which is R. So this is how much? 5 to the 10. So this will end up in 7R by 5. 14R by 10. So this is 7R by 5. Are you able to get me or not? And then this R and 7R by 5 are in parallel. So R equivalent is how much? Basically 7R by 5 into R divided by 7R by 5 plus R. So this is going to be equal to, this implies R equivalent is equal to 7R by 12, I think so, isn't it? Are you able to get me? Done? Is this done? Okay. So this is how you are going to handle it. Whenever you get these kind of circuits, you have to use this method to understand how to handle cubical problems. Okay. Okay, so we did cubical problems, arrangement and all. Now let us move to symmetry part. Symmetry will be easy. Cube was really hard. Cube you have to practice 2 or 3 times to understand. Okay, so let us move to symmetrical part now. Let us take an example of folding symmetry or any kind of other symmetries. Got it? So should I take a easy one or a hard one? Okay, let us take first easy one. There are 2 points A and B. Okay, and I am told to find the equivalent resistance if the resistance are given like this way. Got it? R all are 2 ohm. No, all consider all are 2 ohm resistors. Oh, sorry, they are not divided. Find the equivalent resistance between AB. Find R in AB. All are 2 ohm resistors. So consider R. Whatever you want to consider, you can consider. Okay, no problem. 1 minute. Did you have written the question? Check it. 1 minute. I'm just stopping my presentation. Okay, can you see the screen? Let me check. Yeah. Do it. Is it done? Okay, I'll tell you how to do. Once again, see, this is also a kind of rearrangement. Basically, the point is very simple. This point are connected by conducting wire. So let's suppose if this is C, this is also C or not. And if this is D, this is also how much? D. Are you able to get me? So between A and B, let's suppose if I consider A and B, In between that, there are 2 points C and D also. So mark C and D. Go ahead or not? Because D is connected with A and C is connected with B. Go ahead or not? So let us let me mark differently. A, D, C and D. Are you able to get me or not? So then A to D, one resistor is there. C to B, one resistor is there, isn't it? But then you start C to D. There are two resistors or not here. मेरे को उसको बोलो है ना? 2 plus 2 is how much? 4. Basically, can I write it as 4? And then once again D to C, once again 2 plus 2 is how much? 4. And then once again C to D, one more is there. Which is how much? 4. Correct. Now it is completed or not? R, sorry. This is 2 ohms. This is 4 ohms. This is how much? So once I'm saying you always see when you see the conducting wire, mark it same potential. You'll get the same answer. So this will be how much? 1 by 4 plus 1 by 4 plus 1 by 4 means 4 by 3. So R equivalent is 2 plus 2, 4 plus 4 by 3 means 4 3 is 12 plus 16 by 3 ohms. Is that clear? Are you able to get me? Now let us move to symmetrical kind of questions. First question. Yeah, so this is kind of a symmetrical question. Question is find resistance between A and B. Can you see the screen properly? So I have how many kinds of symmetry? Two, folding and reverse. क्या बोल रहा है? If a circuit is symmetric about in and out terminals or perpendicular bisector of line joining the terminals, then the symmetric branches have same identical current. Folding symmetry is if the circuit is symmetric about line joining terminals, then up and down and circuits are same, and the symmetric points have identical potential. So we can fold the circuit and consider overlap resistance. Achha, this question which I gave you right now is a question based on both the symmetrics, folding symmetry also and kind of you can say reverse symmetry. How? That you can see that if I draw a line joining these 2 points, okay, if I can join a line, so see this is my perpendicular bisector or not? And along the perpendicular bisector you see all the resistances are what? Similar. Are you able to get me? They are basically what? Similar, totally similar, isn't it? So first thing, I'm solving by reverse symmetry. I'm trying to make you understand by the help of reverse symmetry. Then I'll make you understand with the folding symmetry. Okay. Uh-huh. Two methods, yes. Both are almost identical. Are you able to get me? So now look over here. Basically what? This is R, this is R. So basically the point is, let's suppose if my current is I, so this one will be current I1 or not. And here will be current I2. And here will be how much current? I3. And this I1 will be divided into two parts, I5 and I4, isn't it? And if I told you that if the reverse symmetry is there, means along the perpendicular bisector, number of let's suppose resistances are same, then the current in all the branches are identical. In the symmetrical branches are identical. अरे कुछ तो बोलो है ना? So अगर इधर से I4 जाएगा तो इधर इधर से I4 आएगा तो इधर से I4 जाना चाहिए, क्योंकि इसमें क्या होना चाहिए I5 such that इसमें जो करंट आए वो कितना आएगा I1. Are you able to get me or not? If this is I3, then this is also how much I3, and I2 will be divided into, let's suppose, two parts, I6, I7, right or not? Are you able to get me? Let me write it perfectly. I6, I7. So here also how much is that? I7, I6, and then I2. Got it or not? So basically, you only tell me if this is I4 and this is I4, and this is I6 and this is I6. So basically, the point is here there should be no junction now. See, basically the point is like if I have this kind of junction, got it? And this kind of junction is there, and here the current is I4, and here also the current is I4. Here also current is I3. Here also current is how much? I3. Here the current is I6, and here the current is I6. Basically, this junction I have to what I'll have to do? I'll have to connect with the wires with the similar current. So I4, I4, then I3, I3, isn't it? And then I6, I6. So basically what will happen, this junction will break because I have to connect always with the same wire, the same current, isn't it? Same wires means the current should move in the same wire. If the same current is there, it should move in the same wire or not. So this junction will break into this type. Is that clear? So this is the idea of reverse symmetry. That wherever you will find many wire junction, it breaks into a very easy form, and that can be calculated very easily. Are you able to get me or not? So it basically breaks into this form. I'll take this. Okay. So it breaks into this particular form. Is that clear or not? Isn't it? So it breaks into this form, then I can find the current or not easily. Basically, the point is very simple. Let me delete this. So now you can do easily. This is R and R. So basically two are parallel with R. So how much I'll get? 1 by 2R plus 1 by R. Isn't it? क्या 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 अरे देख मान ले ओ सी डी है ना? ओ सी के बीच में क्या है? ओ सी के बीच में ये आर है, ये आर प्लस आर कितना हुआ? 2R, और इसके साथ ये पैरेलल में जाएगा ना, तो आर इक्विवेलेंट बिटवीन ओ सी क्या हो जाएगा? आर इंटू 2R डिवाइडेड बाई आर प्लस 2R. तो कितना हुआ ये आर ऑफ ओ सी? 2R by 3. 2R by 3, एंड देन इसके ऊपर पूरा का पूरा कितना आ जाएगा? Basically, the circuit will be changed like this way: 1, 2, 3, isn't it? And then this is 2R, and then this is once again same circuit. ठीक है? So can you solve it now or not? This is R, 2R by 3, R, 2R, R, 2R by 3, and R. So this is how much? 336 plus 2, 8R by 3, 8R by 3, and 2R. They are in parallel. So 1 by R equivalent का formula आएगा 1 by 2R plus 3 by 8R plus 3 by 8R. So this R equivalent changes to, I'll write it directly, 4R by 5 ohms. Are you able to get me? Is that clear? You can even solve this question with the help of folding symmetry. Yes? Hmm. Correct? You can, you can even solve this question with the help of folding symmetry. Let us understand that. So in folding symmetry, what we say that if we can fold the whole system, look over here, what does it says? If the circuit is symmetric about a line joining terminal, then up and down or left or right, circuits are same. Then the symmetric points have identical potential. So we can fold the circuit and consider overlap resistance in the parallel. क्या मानेंगे overlap resistance को? Parallel मानेंगे. तो हम ध्यान से देखो, if I can consider this line, on this line, the whole circuit can be folded easily or not? Yes. The line joining, सिंपल सी बात है. The line, अरे ये कहाँ जा रहा है सब? What is happening? I don't know what is happening. Yeah. So let's suppose, I don't know where it is going. Okay, so you can understand or not that if I consider the line joining between A and B, means folding symmetry में क्या बोलता है कि join a line A and B, and if you can see between up and down, if there is symmetric resistors, then we will consider it a folding symmetry, isn't it? So let's over this point. Okay, so I'll draw the condition that we can see that between A and B, I have the same potential. So this resistor, then I have this resistor, this. 1 minute. I have this kind of circuits, isn't it? I am considered like this way, isn't it? And look over here. We can consider like, let's suppose if this is point A, this is point B, then R and R, if it will overlap, what it will become? R by 2. I have to consider in parallel. अरे कुछ तो बोला आया ना. And okay, there is one more circuit over here. So ये भी कितना हो जाएगा? R by 2. सारे के सारे ओवरलैप करेंगे. ये भी ओवरलैप करेगा, ये और ये. तो ये भी हो गया R by 2. ये भी और ये भी ओवरलैप करेगा, तो कितना हो गया? R by 2, है ना? ये भी ये और ये भी ओवरलैप करेगा, कितना हो जाएगा? R by 2. Now you tell me about these two. These two are going to be what? Same, because there is, they are lying on the line. So in folding symmetry, we have to remember that if they lie on the line, then I should not consider them on the same circuit. Are you able to get me or not? Is that clear? Now you can see that what is happening. This is current I1, I2, and once again over here along the line of perpendicular bisector. Okay, along this perpendicular bisector line, the resistances are similar or not. So sometimes with the help of, if I also apply folding symmetry, I'll have to apply the reverse symmetry also in this kind of question. Okay. So with the reverse symmetry, let's suppose the current was here I3, I4. So here also the current will be I4, Then here also I3, here also I2, and here also how much? I. Are you able to get me? So whole circuit will be divided once again. This will break over here, isn't it? And then R by 2, R by 2. R by 2 plus R by 2, it will become R, which will be parallel with R by 2, isn't it? So the net equivalent circuit will be drawn like this is 1, 2, and 3. I'm drawing directly. So here R plus R, 2R, because it will break over here, isn't it? And R by 2 will be in parallel. So R plus 1 means, let's suppose this is O and this is point C. So R, okay, R between OC will be simple. R into R by 2 plus डिवाइड बाई R प्लस R by 2 है ना, तो कितना हो जाएगा ये बालक R by 3 होगा ना. So this is R by 3, this is R, 100, okay, and this is also how much, sorry, R by 2, R by 2, this is point A, this is point B. How much is this? R by 2 plus R by 3 plus, so this will become almost around 4R by 3, isn't it? 12R by 6 आएगा, हाँ ठीक है. अरे R by 2 plus R by 2 plus R by 3, तो 4R by 3 आएगा ना. 12 LCM ले लो directly. Okay, so therefore R along AB is how much? Nothing but 2R into 4R by 3 divided by 2R plus 4R by 3. Got it or not? Is that clear? So this result 3 to the 6, 6 for 10, and this is 4 to the 8, 8 by 8R by 10, so that is 4R by. Got it? So this was the question about which symmetry? Folding symmetry. Are you able to get me or not? Is that clear? So magnesia. So if you have symmetry, you can solve using this method. You can easily solve and you can try to find the answer all the time. The last type, which we always get, we call it as infinite ladder. Heard or not? It says like, let's suppose it goes like this way. The ladder goes till infinity, isn't it? Something like this. इस तरह से बना के देते हैं, है ना? बोलते हैं कि यहाँ पे एक रेजिस्टर है, let's suppose R, और इन सारे पॉइंट्स के बीच में भी एक रेजिस्टर. मैं यहाँ पे भी नहीं मान रहा, ठीक है. It is going till infinity. Then find the equivalent resistance between A and B. क्या पूछते हैं? Find R of AB. How to do it? अच्छा, इसके पीछे एक कॉन्सेप्ट है. एक बात बताओ, अगर हम किसी चीज को इनफाइनाइट टाइम्स ऐड करते हैं तो हमें आंसर क्या आएगा? इनफाइनाइट ही आएगा ना. n times अगर मान लो infinite times, not n times, I'm saying infinite times. If I add the infinities, then I'll get the answer as infinity. और ऐसा थोड़ी ना होता है कि infinity plus infinity is twice infinity, ऐसा थोड़ी ना होता है. Is that clear or not? So let's suppose the resultant resistance is x, means let's suppose the R equivalent is how much, is given as x. मान लो मेरा R equivalent कितना वाला x. So basically the result will be also x or not, because I'm getting, see, let's suppose if I add every r till infinity, so ultimately I'll get what? I'll get x if the resultant is x. So infinity times if I also add, I'll get the net answer as what? X also. Isn't it? Are you able to get me? So let's suppose here the simple path ki R between AB is how much? X, which I have to calculate, which is the answer for the infinite resistance, isn't it? Now look over here. That let's suppose this is 2 points A and B. What I did, I just removed one part of the given resistor. What I did, I just removed that one part. Got it or not? Is it going to change anything if I just put a? Acha, I think I'll have to put the resistors over here also. Okay, let us do not think about that. So what I did, if we put then only it will be looking like infinity. Okay, so let us put one resistor. Okay, got it? Okay. So let's suppose if I just removed one part from the ladder, got it? Since all the things are going at infinity, is it going to change anything? Because if I consider even here also A and B, the resultant will be still infinity or not? Infinite, because it is going till infinity, nothing matters, isn't it? And let's suppose whether you calculate from here your answer or whether you calculate from here, the net R equivalent will come as how much? X. So can I just connect that X as parallel, because the resultant of this part of AB is also what? Same, which is X. Are you able to get me or not? So look over here, this R and X are in parallel or not? So equivalent 1 by R equivalent, let's suppose this is let's suppose O and D. OC we measure consider. So R of 1 by R of OC is how much? Simple, 1 by R plus 1 by X. Basically it is X plus R divided by XR. Or I can write R of OC as how much? XR by X plus R. अरे कुछ तो बोलो हाँ या ना? But then ultimately R of AB is how much? Simple, R plus this XR by X plus R, and then once again plus R, isn't it? That is my R of AB. But originally you consider R of AB to be equal to how much? X. So basically the equation we got is simple. 2x, sorry, x is equal to 2R plus XR divided by X plus R. Right or not? So can you solve this? Because I'll get a quadratic equation over here or not. So what I'll get? X into X plus R is equal to 2R into X plus R plus X plus XR. So what I got? X square plus XR is equal to twice Rx plus twice R square plus XR, isn't it? So this and this got cancelled. What I got as equation? X square minus twice Rx plus twice R square is equal to how much? 0. Is that clear or not? So how I need to put it? Can you just put this in equation? Can you solve this quadratic equation? So Ax is basically what? Minus of B. So that is twice R plus minus root under B square. B square is how much? 4R square. minus 4ac, isn't it? 4 a की value 1 है and oh shit, how much I'm getting over here? Minus, oh sorry, this minus, it will change to minus now. This will change to minus or not? So then plus 2r square divided by twice minus b plus minus root over b square by minus 4ac divided by twice ही होता है ना, divided by 2. Okay, so look over here, what I got, x is equal to twice r plus minus, this is 4 2 is 8, 8 4 12. 12 का स्क्वायर रूट कितना होगा? It's not giving you 16, it's giving you, let me check once, x twice rx plus twice r square. I think we are correct on it, no problem. 4ac. Okay. So 12 is like I can write it as 4 3 12. So means 2 root 3 r divided by 2, isn't it? So x is twice r plus 2 root 3 r divided by 2, or x is equal to twice r minus 2 root 3. But minus is not positive because 2 root 3 is bigger than 2r, isn't it? So only plus is possible because resistance cannot be negative. So 2 are common. 1 plus root 3 divided by 2. 2 to cancel. And x is basically, or r equivalent between AB is nothing but r into 1 plus root 3. So your all equivalent resistances are over. All types are over. Is that clear or not? So we completed all the equivalent types of resistances today. Is that clear or not? Done and dusted. Okay. Now you can solve any kind of equivalent resistance problem. Almost we have done every type. Nothing is left. Yeah. Okay. And okay, still we have time. Let us do one last approach, which we were telling, that the use of resistance and KVL to find the equivalent resistance, isn't it? Okay. Yeah, like we will use Kirchhoff's law to find the equivalent resistance in the circuit. I'll give a one basic one, then you can apply, you can understand to apply on many types. Then tomorrow, then after some time, tomorrow there is no class, no? Tomorrow your exams, from tomorrow onwards your exams start. When is physics? Tomorrow. Acha, tomorrow only is physics. Gauss law and all are prepared now? Okay. So this is B, 1 ohm, 2 ohms, 3 ohms, 4 ohms, and 2 ohms. Now, many people will think that I can apply that Wheatstone brace, but it will not be applied because, yeah, R1, R4 is not equal to R2, R3, isn't it? Yeah, so to solve these kind of problems, we apply that fourth process, which we call it as, yeah, Kirchhoff's law to find the equivalent resistance, which is called as KVL. So what we do, we first consider the current, then voltage, and then we apply the KVL over there or not. Yes. So let's suppose this is voltage V. So let's suppose the current initially was I. Outgoing current is also how much? I. So it will be divided into two parts. I1, and here it will be how much? I minus of I1. Are you able to get me or not? And let's suppose here the current is how much, Balak? I2, because it is once again getting divided. So here also the current will be how much? I1 minus I2. Yeah, is this clear? And then the net current over here is how much? I minus I1 uh, plus of I2. Are you able to get me or not? Because it will be added now. net current will be added over here. Here it is I minus of I1. So this will be I minus of I1 plus I2, which results in how much? Simple I. Are you able to get me? So then what I will do, I'll just apply the KVL. So let's say this is first loop, this is my second loop. Okay. So in first loop, if I apply, what I'll get? In the same direction, so minus. So let us apply by KVL. Okay. So let us, if I am applying in my first loop, got it or not? So in first loop, what will be equation? Minus of 1 into I, so minus I1, isn't it? मेरी बातें समझ में आ रही हैं? Minus I1, and in the same direction I2 is also there, so minus of I2 into 2, isn't it? And then I minus I1 is opposite, so plus of I minus I1 into 3 is equal to how much? 0. So इसका इक्वेशन क्या आएगा? हाँ, 3I1 minus 3 minus 4, तो ये आ गया 4I1. I can take minus common, so 4I1 minus twice plus twice I2 is equal to basically 3I. Can I write like this way? This is my first loop. Are you able to get me? Let us suppose if I apply in second loop. Second loop, what I will get? I2 is opposite now. So I2 into 2 is positive, isn't it? And 2 is this upward one is same. So minus of 2 into I1 minus I2, isn't it? And then once again opposite of minus of, sorry, plus of 4 is equal to how much? 0. What is this equation results into? You will see that this results into 6I1 minus 8I2 is equal to 4I. Can you check this? Check this equation. So can you just equate this 1 and 2 or not? So when I will do the elimination of 1 and 2, 6I1 plus twice I2, let us just multiply with some 2 factor, means 2 and 3 factor, got it or not? So 6 3s are 12, 4 3s are 12, 6 2s are 12 and 4 3s are 12. Multiply by on this by 3 and this by 2, such that I1 will cancel, got it or not? So if I do like that, if I apply the elimination method, then I'm writing it directly, Palak, okay, that I1 is equal to, it will come as 8I by 11 and I2 will result into I by 22. Are you able to get me? Is that clear? But still we do not know our I, isn't it? So first thing, my circuit was given, I connected with battery of, I do not know which potential is that V, and then I consider the current. Now I have to relate the battery and I such as to find R equivalent or not. That was our example. So third loop will be like which one? The loop which will start like this way. Let me mark with the maroon one. It will go like this way. And can I just consider these upward resistors, and can I close this circuit or not? Got it. So this is my third loop which relates V and I. Which relates what? V and I. Are you able to get me? So KVL in third, because it is necessary. Because if I don't apply, I will not get the relation between V and I. And to find R equivalent, I need to relate V and I. Okay. So what will be equation? This, the current is going from negative to positive or not? So plus V. Yes. Here it is in same direction. So minus of I1 into 1. Let me write with green. So plus V minus of I1 into 1, isn't it? First this one. Then I have the second one, isn't it? So it is also same. So minus of 2 I1 minus I2 is equal to how much? 0. Is that clear? That's, is this clear? So basically what I got? 3I1 minus 3I1 minus 2I2 is equal to V. I got my relation or not? Now you know your I1, 8I by 11 into 3 minus 2 into I2 is I by 22 is equal to V. Are you able to get me? So यहाँ पे देखो इसको सॉल्व करो क्या आएगा? This will be 22. 8 3 is a 24. अच्छा हाँ हाँ correct, very good. So 8 3s are 24 minus 1, that is 23 by 11I is equal to V. Are you able to get me or not? And you know that what I said, that when you can find the relation between V and I, then the left hand side numerical value is my R equivalent. Are you able to get me? So when I compare this result with R equivalent, I can write now V by I 11. So basically this is my R equivalent. Is that clear? Are you able to get me? Is that clear? So when you have to apply the KVL, when no symmetry can be applied, no reverse symmetry can be applied, even Wheatstone bridge is not applied. So then I have to follow this KVL method. First, I'll connect any two terminal with the battery. Then after connecting with the battery, I'll write the Kirchhoff's loop rule, and with the help of loop rule, I can solve the R equivalent. If you go in HCVMA, this question of cubes has been solved with the help of loop rule. This KVL only, got it or not? By creating 6 to 7 equations. So you can see that, and you can try that at the hardest. If you have more time and nothing to do, you can try that particular example. Is that clear? Okay, so we'll stop over here.